let me talk about SuperGuard. So we are a small company. We are supplying the world with test suite for C and C++ compilers and libraries. We do that worldwide, so also in Asia, where the conference is now. And I want to talk today particularly about library qualification for safety critical applications. Now, if you're work in safety critical applications, then there are rules of what you have to do to make sure that your application is suitable for that purpose. And you are working possibly with high risk applications, in maybe in automotive, but it could also be in energy or many other applications where people are really at risk when your software is not good. So it's important that you also make sure that your software is right and also the tools that you use, and particularly the library, works well. So what do you do for library qualification? Now, the library that you use may come from the compiler or software development kit that you're using, or it could be a pre-certified library. It could also be an open source library. You could even make your own library. Any of these are possible. So there's no restriction in any of these for use in safety critical applications, but you have to take care of the proper procedures of qualifying the compiler. Now, qualifying the library. Now, qualifying the library is mostly done with requirements-based testing. That's the best method that we have to show that the software is reliable. And I've shown here the V model, where on the left side we have the specification of the library, the application, with at the bottom the implementation, the actual implementation. And then on the right side, we see at every level, similar levels of abstraction, we see the associated testing with it. And at every level, you present with the test evidence that the corresponding level is correctly implemented. Now, for the library, that means that we have to have a requirement-based test suite. And the tests are, in a sense, not so difficult. You can write plenty of tests. We have a large collection of them. But you have to show really how they match to the language standard, how they match to the requirements. And I've made here a differentiation between the ISO C standard and the requirements, because they are not the same. You might think, okay, I have a specification, it's an ISO specification, that must be good enough for my requirements. But if you dive into the requirements, then you see that it's really not so simple. So here's an example of a function specification, strn copy function. There's some text over here, and that is the full specification of this strn copy function. Now, if we look a little bit more closely at what it says here, we know that the strn copy function is supposed to copy a string in S1 into S2, but actually it never says so here in this specification. It only says that the string copy function copies not more than n character. It doesn't say it has to copy so many characters. It only says it's not copying something. And then in parentheses, there's another sentence that says there's another stuff not copied here. So there's some kind of assumption of eagerness of this copy function behind this. And that's a bit weird. Now, I'm not saying that this is totally wrong or bad or anything. We usually know what this function is supposed to do. But I want to stress this is not a list of requirements. So we really have to make a translation from this specification to the list of requirements. We can see that highlighted as well by this footnote. The text is really not so clear that it could do without a footnote. So you need that to understand the full text. If we look a little bit closer into the bottom green thing, that's a true requirement. That's really a nice requirement. It says string copy function returns something. That is what it's supposed to do. Paragraph 3 is also a nice requirement. It says, okay, if the array points blah, 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 then you have to do this. So that's a really good requirement. The blue thing, sort of in the middle, just thrown in there, it says this is undefined behavior if you have a certain condition. Now that's also a bit weird to put it right in there. It would be much nicer if these function descriptions had a precondition, a description of the precondition. And then it could say the precondition for this function is that these objects S1 and S2 do not overlap. And obviously, if you violate that precondition, then your behavior is undefined. And the red bit, yeah, that's the really difficult sentence. And we have translated it here into two requirements. So here are the two requirements that we distill from that one sentence where, we differentiate the case where the string is less than n or the string is not less than n. So that's about, where we get the requirements from. Then finally, what you have to do when you do this kind of qualification in safety critical application and safety critical environment, you have to show the requirement, the full requirement traceability all the way from the standard to the test and the test result. So that's what we do in our tools. We present this and we present these records of what we've done, where we say, okay, we are verifying something in the C90 standard here in section 7.11.2.4. It's called the string copy function. That's the title of the section. Then we have a specific requirement specification here with a requirement text specified. And that requirement results in a test specification for the test that is implemented in that specific path in the test suite. And then the test specification text is over here, and we pay attention to boundary values and general cases in this test specification as well. And finally, there's here a result of the test where it says passed. Now, in a proper report, this would all be nicely in a sort of spreadsheet-like model where for every line you have this full definition of a trace from the language specification all the way to the test and the test result. Now, to derive test cases, some methods are typically given, and the four ways to do that here are the analysis of the requirements. So we've just learned about the requirements, generation and analysis of equivalence classes. So if you have something like an addition function, you cannot try to do every value in the integer domain. You have to choose representative values, and those form an equivalence class or equivalence classes. You have to analyze boundary values if you're thinking about mathematical functions, things like infinity, not a number, 0, very small subnormal floating point numbers. All of those are boundary values in the domain. And finally, you have to be able to think as a test designer as well. You have to think about, okay, what are the difficult cases? Another thing that you have to take care of is sort of show that your test suite is complete. And one way to do that is that you use code coverage of the implementation of the library. And that, if you show complete coverage of your library implementation, then you can show, okay, my test suite is complete for this implementation. And that comes up on top of the requirement analysis. Okay, that's my talk. If you want to find us, you can find us at solidsense.nl, and maybe there's a little bit of time for some questions. Thank you very much.
Thank you, Marcel. Any questions from the audience in Shanghai? Ken, I'm unmuted.
Yeah, can you
not? Oh, yeah. So any questions from the audience at Shanghai? From the audience online? Please unmute yourself. Okay, thank you, Marcel. I had a very quick question. So when you showed the slide with all the ASIL A, B, C, and D specifications and the D and how they are each aligned. What is the meaning of those single plus and the double pluses? What do they mean? Do they mean the percentage of importance that each of those components are applied for each?
Yes. I'll look up the slide. One moment. There we go. Share the window. Here we go. Yeah, this slide. Yeah, this comes from the ISO 26262 functional safety standard for the automotive industry, and there they have recommendations of what methods to use for different ASILs. And the ASIL level is the level of risk for the application. So if you have a low risk application, that would be ASIL A. If you have a very high risk application, that would be ASIL D. And for these different ASIL levels, they recommend different methods more or less strictly. So you see, there's a sort of more emphasis on the boundary classes and the equivalence classes for ASIL D. But in general, for this table, there's not that much differentiation. But in other tables, sometimes you do have things that are really strongly recommended for one level or another. And it's an industry standard. It's developed by the industry. So the background is also they keep into account, okay, what are the economic costs of applying certain methods to do this.
Okay. Yeah, makes sense. Thank you. Thank you, Marcel.